let's just do an example. Let's do this example. See how that comes out. So let's differentiate. What did I say? Sine of t raised to the 10th power. Okay, there's an inside function and an outside function. The inside function is x as a function of t. That is, this is the inside function, and this is the outside function. So the rule says, first of all, let's differentiate the outside function. Take dy dx. Differentiate it with respect to that variable x. The outside function is the 10th power. What's its derivative? So I get 10x to the 9th power. I'm using, in this account, I'm using this newly introduced variable name x. So the derivative of the outside function is 10x to the 9th, and then here's the inside function, and the next thing I want to do is differentiate it. So what's dx dt? D sine t, the derivative of sine t, all right, that's cosine t. That's what the chain rule gives you. This is correct, but since we were the ones to introduce this notation x here, that wasn't given to us in the original problem here. The last step in this process should be to substitute back in what x is in terms of t. So x was sine of t, so that tells me that I get I get 10 times sine of t raised to the 9th power, that's x to the 9th, times the cosine of t, or what's the same thing, sine to the 9th of t, cosine of t. So there's an application of the chain rule. You know, people often wonder where the name chain rule comes from. I was just wondering about that myself. Is it because it chains you down? There's a chain. Is it because it chains you down? Is it like a chain fence? What is it? I think I've decided what it is. It's because by using it, you burst the chains of differentiation, and you can differentiate many more functions using it. So when you want to think of the chain rule, just think of that chain there. It lets you burst free.